Thank you very much. Thank you very much. And it is about the Snap packaging system and also the all-Snap distro Ubuntu Core Desktop. So at first, what the hell are snaps and why should we use them? And it is the case that if you have a free software project, it is usually provided as its source code. And this is only something which tech-savvy users can install. And so you are under the usually you are either under the goodwill of the distribution maintainers, that they package this application for your distribution, or you are so lucky that the free software project takes up the work of packaging their software for more than 10 distros and testing it also. And this is really a nice nightmare. And so we look also at smartphones. There it all seems to be much easier. You have many applications in the App Store or Google Play Store, and you can simply pick one and install it. And when somewhere an application is announced, it just works on your smartphone's operating system, independent of the manufacturer, so which all have slightly different systems. And so, Canonical, they have also already made a smartphone operating system. They have given up, but the Ubuntu Touch system, they have given up on it, but they have learned from it. And this was the origin of a packaging format, Snap, which makes everything working like on a smartphone. Snap exists already for 10 years. Since the 14.10 Ubuntu distro, it's available. And this is the so-called sandboxed packaging, one of the available sandboxed packaging methods. And you're up once in a security sandbox, and so it is encapsulated against other apps, against the host system, and it can communicate only through well-defined interfaces. And when the interfaces are able to do, when it is possible to do something nasty, dangerous through the interfaces, these interfaces are not automatically connected. And the Snap Store, which distributes the snaps, they have to give permission on these interfaces. They have control over them. And so with this, you can trust third-party apps. And this way, you can have applications, install applications which are packaged independent of your operating system. And so you are not dependent on your distro maintainers anymore. And with this, we have operating system distribution independent packaging. And so the free software project only needs to package once and test once, and then the resulting package once on many distros. And this works mainly because all the dependencies, all the libraries which the package needs, come with a package and do not need to be provided by the operating system. And with this, we have the smartphone-like user experience. So, and Snap has also one special advantage against other sandbox packaging systems. It's that snaps cannot only be made from desktop applications, but they can also be made from system daemons, system applications, even from the kernel and from a base operating system to make up an all-snap distro. And I will talk later about that. Then the packaging with distribution-independent packaging like Snap, the packaging moves from the distributions to the applications, because the application projects can make distribution-independent packages, and so the distributions do not need to package all the applications anymore, and the applications get even updated independently of the distro, so you can have a much newer browser than the release of your distro. And with this Snap, we can form immutable distros, and Snaps itself are some kind of immutable applications. So now we go deeper into Snap packages, and the properties are that the file system content of the Snap packages is a read-only squash-fs file system, GPG signed, and so this is immutable, and it includes also metadata, which is needed for the installation, also to know which interfaces it needs and so on. And when we install a Snap, for each Snap also an encapsulated writable file system is created, so that the Snaps can store status, user data, and so on. And the updates are atomic updates. The Snap is always updated as a whole, as the file system is immutable. The whole file system is replaced by a new one. And to make the updates, to accelerate the updates, the Snap Store provides binary diffs, so that only deltas are downloaded and not always the whole Snap. And this works on many distros, and it exists already for 10 years. And for the security, as I said, we have a read-only system image file system. With this way, nothing can be manipulated. And it is GPG signed, so it can be trusted. And we have a confinement which encapsulates the Snap. It's app armor for the file system, seccomp for the system call restrictions, and namespaces. And the executables are started with special wrapper scripts, and this way the executables can run in this encapsulation without the standard system file system. And this is root safe because the Snap is encapsulated. When the Snap's executable is running as root, it cannot damage anything in the host system or in another Snap. And therefore, especially daemon Snaps, the daemons are run as root. And they do not need and we do not need to make security by having special system groups or system users to manage permissions. And they are also storage efficient because the immutable file system is compressed, and when it's mounted, it does not get uncompressed. The data is uncompressed on the fly when it's accessed. And then we have also, if we have, for example, GNOME application snaps, they would bring all the same GNOME libraries, and these are many, and so we have some snaps to share parts, so-called content provider snaps, which, for example, the GNOME content provider snap contains all the GNOME libraries, icons, and so on. And the core snap, the operating system core, is also a snap. And this contains all the libraries, all the standard libraries, which are used by most of the packages. So, and for snaps to communicate, either with the host system or with other snaps, we have so-called interfaces which do a well-defined communication for a well-defined use case. For example, we have a cup snap, a dbus snap, a cups interface, a dbus interface, a network interface, dbus interfaces, all interfaces for special use cases. And when one creates the snap, one selects which interfaces one wants to use. And so one can well define how the snap communicates. And under the interfaces, there are some interfaces. They are not very dangerous when one connects them. For example, the cups interface. With this, you can send print jobs to cups, you can pull the list of available printers from cups, but you cannot delete cups queues or so. And so this is a harmless, safe interface. And so if you upload the snap to the Snap Store and someone downloads it and it connects to the cups interface, this interface is auto-connected. But there are also dangerous interfaces. For example, the cups control interface, which allows the snap, which is connecting with it, allows the snap to do everything with cups, to create and delete queues, to read the print jobs of every other user, and so on. This is dangerous, and therefore, when you connect to cups control in your snap and a user downloads it, cups control is not auto-connected. The user has to manually connect it. Or you get special permission from the Snap Store team so that that for the user it gets auto-connected. So, and now also important for snaps, the updating mechanism. The updating cannot be done by replacing some files of the snap. So always the immutable file system of the snap is replaced as a whole when the snap is updated. And it does not overwrite the old immutable file system. The old immutable file system is we keep as a backup should the new version of the snap not work. So when we do the update, the original data and the original snap, the writable part also, they are saved. And the new snap, the new immutable file system is put into its place, and the writable data is kept from the old version so that the user does not lose their data on the update. And then when, in the case that the new snap, the user is not content with it, it somehow not works, the user can say, I want to step back, and then the backups are taken back into place, and the user can continue on the old version. And if the snap is, for example, a kernel or boot system snap, and due to some problem, the system is not booting anymore, then the stepping back is even done automatically. So now we have learned about snaps. Now I will tell about an all-snap operating system. And the simplest case of an all-snap operating system is Ubuntu Core. And this Ubuntu Core was the reason why we have Snap, because Canonical has 10 years ago worked on an operating system for IoT. And there they wanted to have the immutable operating system with atomic updates. And so they have created Ubuntu Core. And Ubuntu Core is completely consisting of snaps. And it contains, and the operating system itself contains as first the gadget snap. And this is the snap which describes how the storage media is partitioned and how the system boots. And then there's the kernel snap. This is the kernel of the system. And so you see the kernel is in a snap. And there's a core snap. This is the operating system core. These are all the common libraries which every program is using, the shell, systemd, and things like that. And so this makes up an operating system. And on this operating system, you cannot install Debian packages. You can only install snaps to add applications to it. And it contains naturally also snapd in a snap, so that the snap installations and updates get managed. And this is a simple operating system. It is not. It has no desktop, and therefore it is, as it was designed for IoT, it could also be used for server tasks. And after that, Snap was continued to be developed, to be installed also on classic installations of Ubuntu and on classic installations of other Linux distributions. And then naturally also desktop applications got snapped, and content provider snaps for desktops like GNOME or KDE were introduced, and so on. So that on a classic distribution one could install also desktop applications as snap. For example, Ubuntu comes with Thunderbird and Firefox and some others as snap and not as Debian package. So and here we see we have the Ubuntu Core operating system, and we have the applications, and everything is encapsulated and separated from each other. So no uncontrolled access between two of these pieces. So, and now, in the last year, we have introduced desktop support to Ubuntu Core. And so we have extended our Ubuntu Core operating system by one very important component, and this is the desktop session snap. Here, Ubuntu Desktop Session Snap, and this snap contains Wayland as the graphical base, and it contains GNOME. And so we have the GNOME desktop. One can naturally make also desktop session snaps based on other desktop environments, and there are already more than one effort to package KDE this way. And with this, we have extended Ubuntu Core to be a desktop distro. And so the applications we install can be also desktop applications, because we have a GNOME desktop there. And these additional bases, this is as each application, when you snap an application, you have to base your snapping on one of Ubuntu's LTS distros, 22.04, 24.04 or so, and for each one there's a core snap or a base snap, and this snap contains these common libraries. And now it happens that you install applications on your Ubuntu Core or Ubuntu Core desktop system which are snapped with another base system as your operating system, and so the additional base system snap will be installed so that snap has also its correct distros. And the nice thing is, every snap you can replace by another. So, for example, you can add other desktop session snaps to get other desktops available. So that, for example, when you start with a Ubuntu Core Desktop with GNOME, you can later on add KDE and then switch to KDE. Or you can replace the kernel snap. You can put a gaming kernel in. And so you have the flexibility with this operating system, more flexibility even than with conventional immutable distros, because in conventional immutable distros, everything except the apps is one immutable part, so you cannot replace the desktop or the kernel. Thank you. So as I said, we have principally Ubuntu Core, but we have added a desktop session snap, and one thing is, now you are thinking about how do I do development on it, because we have everything encapsulated in snaps. We cannot have a terminal which can access the whole file system, and I can simply install something from source and to then work on it. And what we do to do development. We take the graphical front-end workshops, and this creates LXD containers of classic systems, classic Ubuntu, but also classic systems of Red Hat, SUSE, and many other distributions. And so in these systems, you can do development. But we cannot release this yet. This will take some time because there are still some to-dos. For example, we need to have NVIDIA driver support for gaming, and the printer setup tools, they work with the CUP snap and with CUPS 3.x. They are still under development to be changed to work in this encapsulated environment. We also need scanner applications to be able to add scanner drivers, which is also under development. We need also more development support. For example, that we have an IDE which is installed as a snap and can access your LXD containers. And TPM full disk encryption, remote management with Canonical landscape, Active Directory login, because Ubuntu Core Desktop is also very nice for the corporate desktop where one wants to manage hundreds or thousands of machines. It's much easier with this all-snap immutable distribution. And distribution infrastructure, to be a distribution, to provide a distribution like Ubuntu Classic, you need to create and provide ISOs, you need to do testing, you need stable release tracks, documentation, and so on. And that's all. And now, questions? Yes? Yes. The kernel snap, you have a kernel. The kernel snap, you have a kernel which comes in a snap, but I don't know exactly how it works. Perhaps Ken here?
So yeah, the kernel snap is a bit of a special snap, obviously, because it needs to be able to provide kernel modules and things like that get loaded at boot time. But the OS, which is Ubuntu Core, has interfaces that can deal with the kernel. But the kernel can be updated independently of, like, say, the operating system image. It's a separate snap, and it gets updated the exact same way as other snaps, but it is a special snap.
Any other questions?
Yeah, I wanted to quickly ask about AppArmor, because is this on? Yeah, I think so. AppArmor is not available in all distros, right?
Yes, this is one important problem of Snap. Not all distros use AppArmor. There's one half of the distros using AppArmor, the other half of the distros using SE Linux, and you do only get the full encapsulation working when the distro uses AppArmor. This is still a little bit disadvantage of Snap. The best thing would be if we succeed to convince our Snapd team to add optional SE Linux support. If they would go through all the interfaces and map them through to the appropriate SE Linux rules, because now each interface is creating rules for AppArmor.
But I saw in your slides that it's file system sandboxing. So there's a new thing called landlock in the kernel. Could it maybe use landlock for sandboxing file system access? 'Cause then okay. Fair enough. Yeah, okay. Okay, thanks.
Any other questions?
Yeah, I was curious on Ubuntu Core for the IDE support. Are you taking like a VS Code approach where you connect remotely into containers from a snap that's outside of it? Or are you thinking more of like running IDEs within a development container of like Ubuntu Classic?
I'll take this one.
Yes.
It's
think
not
I
fully
will come closer to you, because when I'm standing here inside, there are no speakers, and I don't understand you well.
Till, I'll take this one. So it's not fully designed yet what we're going to do, but basically in Core Desktop, for example, we're bundling LXD in it so you can run containers and things. And the idea is when you install VS Code as a snap, it'll have the ability to talk to that container. So you can have multiple containers, and VS Code will be able to drive the individual containers. There will, in all likelihood, be a seeded container inside the image that allows you to install, say, Debian packages and things like that, that is just for running things that aren't available as strict snaps. So when you go into the snap store and say you want to install VS Code, which is a classic snap that has a lot of permissions, it would actually automatically install it inside of this container and run it from inside that container. GNOME Shell will surface the icon. When you launch it, you're running it inside that container. But it would be able to drive development in any container you have.
One follow-up. Are you working on a replacement for like Microsoft's proprietary container integration?
Not necessarily, probably our own thing.
Okay, cool.
I think
Yes. Yeah. Thank you very much. So,
thank you.
And sorry, Ryan, that we have perhaps a little bit over one.